Okay, cool. So thanks again very much for having me. I will today talk about bioimage analysis code generation using Bia-Bob. So I've given similar talks before, mostly focusing on language models, on the technology behind. Today I want to focus a little bit on the front end, on how to use this technology in your particular environment. In particular, when you work with Jupyter notebooks for data analysis, this may make a lot of sense. So just a very brief introduction into large language models. This technology, we are now talking about it on a daily basis, more or less, because it has a lot of impact on our daily life, on our research. And it's basically comes from the world from translating text. For example, here you see on the left side English text, and on the right side you see German text, and a neural network in between, which allows the translation between these words. What is also basically just a translation task, I would claim. If you, for example, have an English very short sentence like here on the left, open helacells.tiff, and then you translate it to Python. So you see here an import statement and a single line which will open this image and save it into a variable. And this is basically what I'm talking about. What I also do my current research about is how to use this technology to bring basically Python coding to people who may not be super hardcore developers, but who know what they want to do. So yeah, and there's like a lot of literature. If you want to dive a little bit into this, I would recommend this particular paper, the SWE bench. Can large language models resolve real world GitHub issues? So if you tell a language model here, I have a problem with my code, can you please fix it? Language models are capable of doing that. And they, back in the days, they published numbers about that. So they discovered that something like 5 or 10% of issues can be solved. And this is already some time ago, because it's like half a year old, this paper. The numbers are already increasing. So it has been proven that this can be achieved. And now many research groups around the globe are working on improving that and making it possible that you can really express your problems in English language in a GitHub issue, for example. And then there's a solution generated by a large language model. If you use ChatGPT, so the screenshots are already a little bit older, may look a little bit different today, but the capabilities are certainly the same. If you use ChatGPT from OpenAI, you can upload an image and you can say, please segment the nuclei in the blue channel of this image, and it will certainly do that. So there will then be a segmented image. There will also be an explanation of what it might have done. And if you click on this little button, you can then see that in the background, it was generating Python code. It was executing this Python code, and it was running this Python code in order to get this result, which you see there. So it's not a neural network which takes your image and makes a new segmented image out of it. It's a neural network which produces code, and this code does the image processing. So this is, I would say, currently state of the art, even though these advanced neural networks, which can do this maybe in one shot without code, may pop up at some point. So why am I talking so much about code generation? Why am I working on this? In very general, large language models are often criticized for limited reproducibility. For example, if I tell a language model, say A, it may say A. But if I ask it again, it may then say a exclamation mark. So the output is already different, and it's also the same with code. So if you ask it to produce code to do that, to do something, the code will look different. We can also later see that in the demo that from time to time, the code which is generated looks a little bit different. And that's kind of an issue if you think about reproducible science. If you think about, if I want to do something today, I want to do it again tomorrow the same way, language models might not be the direct way for doing that. And that's why I work so much on code generation, because if you ask a language model to write Python code that says A, it will do this, it will produce this Python code. You see it here on the bottom. And no matter how often you execute this code, the output is always guaranteed to be A. So to be clear, I would not say that the code should be regenerated by the language model. I would say you ask a language model to produce code. You can then also by yourself modify this code to be absolutely picture perfect. And then you run this code and you do not talk about this particular image analysis problem, for example, to the language model again. And this is basically a way to exploit the power of large language models in code generation in solving a scientific data analysis problem while also being reproducible. You basically ask it to produce code, and afterwards you continue with the code. So In very general, then we have to ask how good are large language models actually for this particular task, for bioimage analysis. If you look out in the literature, you will not find anything, maybe except the thing we did some months ago. So you will find a lot of benchmarks about data analysis in general, about code generation in general, about things which have nothing to do with image analysis at all. But bioimage analysis benchmarks were not there before we had to make one because we need this for our science. So imagine we have a test example case, this particular use case. I have an image on the left. I would like to binarize it. I would like to segment the individual objects. Connected component labeling is the technical term. Then I want to measure the area of all these objects, and I want to determine the average area of these objects, in this case nuclei, in my image. In Python expressed, this code could look like this. You also see on top, there's an English explanation. It's the prompt you will use for the language model. So we send to the language model this prompt, this kind of short text explaining of what we want to do. We keep for ourselves, we do not show the language model. We keep a reference solution. And also we do not show the unit tests to the language model, but we have some Python code unit tests, which can be executed in order to figure out if a solution is correct. So we ask the language model, can you please, for this English text on top, can you please write code which solves that problem? And then we execute the code on the bottom in order to test if this Python function written by the language model is correct. So we formulated something like 57 of these use cases. There are currently 18 more on the way. So we had some contributions from people from the internet, actually from around the globe, which is really amazing. And if you feel experienced and have some time in writing a couple of these test cases, feel free to contribute. You can also become co-author, no big deal. If you have like something like 3 simple cases or one more complicated case, reach out, send it to us, send a pull request. Then we have a better covered landscape of bioimage analysis. For example, we have at the moment nothing in the context of electron microscopy, and we have nothing in or almost nothing, I think 1 or 2 test cases from super resolution microscopy. So if you work in this field, you have some Python code snippets where you think language models should be able to do this or should not, also fine. Reach out and we can build it in. This is really open for contributions, and co-authorship is offered. So back to this test case. If I ask now a couple of language models, you see here on the bottom, there's these names, Claude 3.5, GPT-4o, GPT-4 Turbo, and so on. We can ask these language models to produce code. We do this 10 times. And then we have the pass rate. So how often the language models produce code which is actually solving this problem correctly. On the very left, there's reference. That's our reference code written by a human, and how likely it is that this reference code is like has the correct result. It's always ideally always one, kind of a sanity check. And then you see all these language models, how they perform. On the left, Claude, GPT, that's these commercial models which cost some money when you use them, are very good. So they solve these problems in 10 out of 10 or 9 or 8 out of 10 cases. The more you go to the right, and it's really ordered by quality, you will then find a lot of, mostly open source, open weight models, which are not so capable. But also, if these models are capable of solving these problems in something like half of the cases, that's still super amazing. Because if you think about a human solving this problem by writing these 5 or 6 lines of code, if you ask me, Robert, can you please write this code? My chance of achieving this in a single shot, writing the code and executing it, and then this execution is correct in 100% of the cases, my personal likelihood, my personal probability or unit test pass rate is certainly not 1. So I can not achieve these good results, I would claim. So we have a couple of those use cases. You see here on the right, it's now an extended plot of the thing I have shown you. And you see that basically there's a couple of test cases on the very top where these language models are super capable and they can solve these problems, no big deal. And you see on the bottom of this image on the right that there's quite some use cases where none of the language models, neither the open ones nor the commercial ones, were capable of doing that. And on the left side, you see a summary, and it's ordered by quality. So the best model we have seen so far is Claude 3.5 Sonnet, followed by GPT-4 Omni. So that's these 2 models which are super good. Oh, one mini is released something like 3 weeks ago. performs in the same range. So they have a pass rate of about 0.6. So that means something like if you ask a language model 3 times for producing code for these test cases, they will solve this problem successfully in something like 2 out of these 3 cases. So again, that's the commercial models which are on top. And later in the demo, in the exercise, I will give you a notebook where you can try out a free model, which is provided, like you do not have to pay for it. But you also see here that it's the quality of these models are much worse. So if you later try it out and you see, you have the feeling that these open models are not as good, then you may want to try out the commercial models as well. Or I must really say it, I use the commercial models on a daily basis. And I do not use the open models because they are not good enough for me. Nevertheless, you can later try them out. Okay, so let's talk about Bia-Bob. So what is Bia-Bob? Bia-Bob is a tool which helps you in a Jupyter notebook to write code by prompting with English language. So you see here, I start with this percentage Bob, and then behind I say something like load the blob's TIFF image file and show it. And then Bob will summarize what it's going to do. I will load the blob's TIFF image file and display it using an appropriate visualization function, and it will generate this code. Then you can execute this code and you may see this image. This is, I'm saying here, first steps, keep it simple, because I also show a lot of advanced examples because this technology can achieve a lot. But in particular, when you are a Python beginner, when you use these tools for the first time, try to go on in these small steps, right? Like one sentence, what you want to do, what you want to achieve. And then when there's code coming out, read the code carefully and learn together with the language model how Python code works for achieving these kind of tasks. You can, of course, also make it a lot more complicated. That's what I just mentioned. You can, for example, with a bullet point list or just multiple sentences, you can say things like, hey, load blobs.tiff from disk, segment the bright objects on a dark background, measure area and perimeter of the object, show the original image, the segmented image, and the area versus perimeter plot side by side using subfigures. And then it will generate code like this. So this is really something I would not recommend to bloody beginners, but it is something this technology can really achieve. So if you then execute this particular code, you can also see here again in this screenshot, I was using Claude 3.5 for that, you see the original image, the segmented image, and this plot as I was instructing it. So it actually works quite nicely. Additionally, what I also like a lot, which I also think will have a lot of impact in the future, is that you can also pass images to the language model. It becomes then a vision language model, a VLM. So you see here on top, I have here passed this image, which is a variable which I created in my Python Jupyter notebook before. And I can ask this language model, what is in this image? And then it will say, the microscopy image shows numerous cell nuclei scattered across dark background. And it basically has to express this in a sentence because it's a language model. It takes what is written down so that if you afterwards ask for code for processing that the content of the image has been written down as a text at least once, because otherwise the language model would not be able to produce code which fits to this image. It has to speak out what it sees once. So here in this case, the biologist might then say, hey, that's right. And then afterwards, we can continue asking, and you see already my question is very specific. What deep learning-based Python library could be used to segment the cells? And then it may propose CellPose. It may also propose others. So then also the computer scientist might say, yeah, that makes a lot of sense. So let's go ahead. Bob, please write Python code for applying this algorithm to my image. Make sure the result is a label image of integer type and also visualize the result using an animated curtain. And you see here already the language I'm using, label image of integer type requires some image analysis knowledge. And that's what I also often say to people is, you cannot analyze images with a large language model if you do not know how to analyze images. So you have to have some basic knowledge about image analysis. Otherwise, you cannot guide the language model the right way down the road in order to achieve this task. So fancy animation. It will then produce code like this, or it may, right? In something like 50% of the cases, presumably. And it can then come up with a visualization like that, where you can say, yay, and you have your segmentation. Also, in this case, if you want to proofread this code, you need some Python programming skills. If there is a small typo somewhere or a function is called a little bit differently, you may want to be able to understand that. And that's why I would also say you cannot ask a language model to solve complex image analysis problems in Python if you do not speak Python. So that's why having some basic understanding of image analysis and basic understanding of Python is required if you want to use language models for these tasks. Yeah, so can be extended in an advanced direction. I will give some more examples of things you can do. You see now here on the left, I'm loading an image and I'm visualizing it. So that's code I might have written myself. And then you can present an image to the language model to Bob like this. It's what I've shown on the slide before. And then you give some more detailed instructions. For example, please write a Jupyter notebook, so an entire notebook, yeah, for processing this image. The file name is this and that. At the beginning of the notebook, please describe the image it is made for. That's what I mentioned earlier. The language model has to speak out the content of an image once so that the code which it writes afterwards fits to this content of the image, so that the processing of nuclei uses the right algorithms and not like random image segmentation algorithms. I'm also saying here furthermore that it should please explain what you're doing in detail because I'm a Python beginner. So here you can basically ask the language model to provide an explanation which is like not as advanced to be then able to learn together with the language model how it does. It will then answer with a sentence like that. A new notebook has been generated and you can click on this link and then this notebook will open. And in this particular case, I made a screen recording. You see step by step a piece of code. It's like step by step showing the intermediate results. And then by the end, it will print out how many nuclei there are. And this is why I prefer using Jupyter notebooks, because you see these intermediate results. You can read these something like 5 lines of code. You can understand them, and then you can go to a more advanced image analysis problem in your next project. So learning is really easy with Jupyter notebooks in very general. And if you have a language model which you can discuss with inside this Jupyter notebook, that might be useful as well. Some more examples. I often see, also receive Jupyter notebooks from colleagues with a lot of code, which does super amazing stuff, and not a single explanation in between. So it's unfortunately very common that many of us data scientists are lazy and do not write comments or explanations in their Jupyter notebooks or in their code in very general. So you can say, Bob, please modify this notebook by adding markdown cells between the cells, and also add a markdown cell at the very beginning that introduces the entire notebook shortly. And then it will come up with an introduction and a step-by-step explanation of what the code is doing. So when you get some code from a collaborator and you do not know what it's doing, and maybe the collaborator is not responsive or on vacation or whatever, you can ask a language model to put some explanations between the code lines to have a better understanding of what the heck is going on. This can be extended to other languages. You can also say, Bob, please translate notebook to a different language. And here you see different examples. And now, depending on which language you speak, I'm quite good in German. You can also see that it uses some words like Bildschnitte in the middle, which is not a common term in image analysis in German. So it's like making up some terms. And here you nicely see that it gives it very best. And I think these notebooks are understandable in all presented 4 languages. But sometimes the wording is a bit strange because language models are obviously trained on a very general human use case and not so much on scientific image analysis. That's why sometimes there may words appear which are not super useful, but I hope still that these translation of notebooks into other languages make the technology image analysis more accessible to more people on the planet. Good. I will introduce some details about the installation because it is a little bit tricky with these language models to get them running on your computer, to get access to them. I will partially run a bit over these slides, might also be a bit boring. You can download these slides. There should be a link in the chat. And then dependent on which language model you want to try out later, you go to this particular slide and you can then look at the details in more detail. I was asked in advance to explain a term. RP keys, that's something super common among computer scientists. So we learned this something like the 2nd or 3rd semester. For us, it's very normal. And obviously, to a general audience, people do not know what an API key is. So application programming interface is the long explanation of API. And I would very shortly phrase it as a modern kind of password. So basically invented to avoid entering usernames and passwords again and again. So let me quickly show you how that works. So on the left, you see my computer. On the right, you see a remote server. This can, for example, be Google Online Services as a very general term. So I log into Google with my username and password. And there I can search, I can upload my documents to the Google Drive. I can use language models on the Google AI platform, and I have a calendar and maps and whatnot. So there's a lot of services over there, but I only want to use one service. I only want to use a large language model, and I want to basically store my password locally so that I can quickly use large language models over and over again without having to log in again. So I log in, and then from the server, I create an API key. And this API key is only valid, certainly for my user account, but only valid for some of the tools over there. So this API key allows me to, for example, use the language model on the Google server, but it does not allow me to read my emails or similar. So and then I save this API key on my computer, so in the environment variables. I also have a screenshot and showing you how to do this on a Windows machine. And then next time I will log in using my API key. And then I do not have to enter my username and password again because this API key is stored on my computer. So you can then just open a notebook and you can communicate with OpenAI large language models or with Google large language models without having to enter your username and password. This is what API keys are for. What is very important with API keys is that you should never share them with others because others can then use the services as if they were you. And in particular with paid services, that's really tricky. So if you upload your API key for Google AI or for OpenAI to the internet, and then strangers will use this API and you will pay for it. That's why I keep these API keys really secret and do not show them in Zoom meetings or whatever. Really make sure that they are secret. And furthermore, if it also happened to me a couple of times that I was sharing my API key in some scenarios, you can revoke them at any time. So you can log into the Google server and say, this API key, please invalidate it. Whoever has it now should no longer be able to access it. So that's kind of securing this kind of access from the other side. So it's meant to make our life safer. So here I have now some screenshots, as I mentioned before, where you can get these API keys from these different vendors. So here's Anthropic, Claude. You can go to their website. You can click on Start Building. You have to log in. You have to basically, I think with a Google account, you have to register, which is very simple. And then you can click on API keys, and you will then have a list of keys, and you can click on Create Key. It's quite trivial if you know where to click, and that's why you have these screenshots here. Then OpenAI, it's also a bit tricky because you see here 1, 2, 3. You have to click a bit around to find that, but also there, it's just creating a new secret key and then you copy it over. And I was also, so there's the two models, Anthropic, Claude, and OpenAI is the two commercial models, which are very good in our benchmark, which basically where there's proven that they can help with image analysis problems. And then there's a platform, I think they are just online for something like 2 or 3 weeks. GitHub models where you can also create an OpenAI, where you can also create an API key, and you can then use their different models. You can, for example, also use OpenAI GPT-4. It has some limitations compared to the actual GPT-4 from OpenAI, but it's free. So you can use this one if you like and play a bit with it. It's nicely compatible with Bia-Bob. So that's maybe an option in order to get access to an API key for playing with it for free. Yeah, and you have to also click on this particular button. Again, you can download these slides and look that up later when you create your key. Then I was on a conference yesterday of the German AI Society or community. And there is apparently an online services from the German Society for Scientific Computing, where you can get also an API key to open models. So that's the not as good ones, as I mentioned before. You can also get one here. The fun is, I would really love to know if it also works for everybody from other countries. They say target group everyone. And they were also claiming during their talk yesterday that everybody can access. You do not have to be a German academic. You do not have to be like in a university or something. So apparently everybody can access. So you can also here apply. I tried it yesterday. For me, it took half an hour. So after half an hour, I got an email from them after filling out this form and here really like marking that you want to use the API to the chat service. maybe after half an hour, you have an email giving you an API key, and then you can access language models with this one. When you have your API key, you have to enter it, you have to save it in your computer so that you do not have to enter it again and again, like with passwords. You have to save it in the environment variables. And on Windows, I typically do it like this. I go to the start menu and I start typing environment variables until this thing here shows up. And then you click on it, and there will be this window, and you have to click again on environment variables, and you will then find here a long list of things. So in my case, there is already an OpenAI key stored, which is a bit longer than just that. And you can click here on new, and then there will this window open. And dependent on which model you have chosen, the OpenAI, Anthropic, or the GitHub models, you have to enter this as a variable name and then the key in the second field. And if you have saved it like that, like closing all these windows, you afterwards have to basically restart your terminal if you have your terminal already open, and then you can continue installing it. And I think this is something Ricardo showed you last week, how to set up a Conda environment. So you see here, this is a particular command. You see Haase and Hüpf Bia-Bob environment.yaml file. So it's basically an environment with some image processing libraries and Bia-Bob, which you can install in one shot to try out these things. Afterwards, you can activate this environment with the command bobenv. And then you start Jupyter Lab. In your Jupyter Lab, you would then click on making a new Jupyter notebook. And here you can then say from Bia-Bob, import Bob, and then with %Bob, you can start typing and it will then respond to you. You will also see here in the default, that's the default case, that it is using GPT-4. If you want to use a different model, it will be a little bit more complicated compared to this one. There's also everything I was talking about now is also again on the website. You can read it there. And again, you can download these slides. Here's a list of compatible models. I was, for example, not talking about Google today. Also, the Jamba model is pretty new to me. Command R and Phi and Llama. I have very limited experience with these open models, but we know from a quantitative comparison that they cannot really compete with the commercial models. Nevertheless, they are available and you can try them out. And here you have another slide showing how to use these particular different models. So for example, if you want to use Anthropic Claude, you have to initialize Bob once with this command specifying the model you want to use as a model and also as a vision model. That's the part of the software which can perceive your images. Also, the code here on this slide, you can download from the website. You do not have to type it from the slide. You can get it from the website, which is linked here on the very bottom. One final hint I would like to give, I will also later show it in the demo again, but I also have it on the slide here. It would be nice if we could establish good scientific practice in this context. So whenever we use a language model for generating code, it would be nice if we would save the prompt which was responsible for generating this particular piece of code. And in Jupyter Notebooks, you can, for example, do this by turning the type of a cell to a raw cell. And then this thing will not be executed anymore, but it will be there for documentation purposes. So that might be nice for example, if you later want to know, oh, here's a long piece of code, how was it generated? You can then look it up and you can then see which prompt was responsible for this particular generation. And I will just give some hints also towards other technologies because LLMs are everywhere. So you find these chat windows. So I think ChatGPT, everybody has tried it out by now. Also Claude, where I mentioned already that it was a tiny bit better in our benchmark, is also an online platform where you can sign up. And I think you can also use it for free. The open models are, for example, accessible via the Hugging Face platform. You find here also links on the bottom. There's quite advanced tools in this particular context. So Napari ChatGPT, the bioimage.io chatbot. There will be a YMIA Python seminar series talk about the chatbot, I think next week. And also next week is the Globaya seminar about Napari ChatGPT on Friday. So 2 Zoom meetings where you can sign up and hear other ways of interacting with language models for achieving similar tasks, image analysis with this advanced technology. There's also a tool called Jupyter AI, which is a bit more towards data analysis and certainly not so much towards image analysis, which is very similar to Bia-Bob. So you may also want to try this out. Here you use the same API key. The configuration is a little bit different. But then also here in a Jupyter notebook, you can basically ask to generate code. For those of you who are a bit more advanced coders, you may want to try out Ada, which is a tool where you on a terminal can basically say, oh, I have a complex project with many, many files, and now I would like to reconfigure my project in this and that way. So really advanced software engineering can be done with language models as well. Copilot, I think also many of you may have heard about this one. There's also GitHub Copilot Workspace, which is an online platform where you can do also complex tasks where multiple files are involved. And Cursor is one of the integrated development environments also for software development, where large language models and artificial intelligence are deeply integrated. Another project I'm working on, which is also a lot of fun, you will see, or you may see on the one or the other GitHub repository I'm maintaining, you can ask questions like, I have a 2D time-lapse data set as a NumPy array, and I would like to visualize it as an animated GIF. And it's possible that an artificial intelligence named Gitbob, which is obviously related to Bia-Bob, may then respond and may answer your question. So it's also the same technology, different user interface, hopefully useful for the community. And what we also did, we built it into the Fitchy script editor. You can also download that. You find on the ImageSC forum there, you find some instructions in the download link. But I also must really highlight here in this context, I have not seen any large language model, also not the commercial ones, who support image chain macro well. So the use case I'm showing here, you see on the left side, there's code. And I asked the language model, can you please put comments in between and explain what the code is doing? This use case works quite nicely. If you ask the language model, can you please generate image chain macro code for segmenting my image? It will most likely come up with code that does not work. So we have no quantitative benchmark here in this context, unfortunately, but my experience is that language models are not so much capable of writing image chain macro. They are more used to Python. Okay, summary before we come to the discussion and the demo. So obviously, large language models can generate code to analyze biological microscopy images. We can learn how to use them. We do not have to. But there's an opportunity, I would say. And in order to do this properly, we have to also understand bioimage analysis. So we cannot do something which we are not capable of with a language model. So there's language model can make our way shorter, can make us more efficient, and it can also help us exploring, for example, Python libraries we have not known yet and show us a bit how they work to process images. But if we do not know how to process an image in very general and how to do quality assurance to make sure that the code does the right thing, then we are doomed. So that's a nice opportunity to, for example, attend an image analysis lecture at the university and then use a language model to apply this knowledge you have from this lecture to your scientific project. I would like to thank a lot of contributors, in particular to the benchmarking project. It was really great that we kind of worldwide can work on this. I want to thank Elena for testing Bob quite excessively from time to time. And I would like to also thank the communities and platforms who, some of them offer these language models for free, which is fantastic. And others like YMIA and German Bioimaging are organizing these meetings where we can talk about that. So that's from my side for now. Maybe we do some questions before we then switch to a demo.